Okay, let's try this. Here goes nothing. Got my dogs eating their dinner in the background. Sorry, guys. I let him inside at least. At least I was that nice to him. It's not that cold out, though. So the previous one, we noticed that if we put a minus in here, we shift the graph that away. If you add a number here, something else happens. So now you can plug in 0 here. Not the nicest thing in the world. You can plug in 1 here. You can even plug in negative numbers. For example, we already said if you plug in 1, 1 plus 3 is 4, square root of 4 is 2. That works. Think about going this direction now. If you plugged in negative 1, 3 minus 1 is 2. The square root of 2 exists, just a decimal. Plug in negative 2. That would work. 3 minus 2 is 1. The square root of 1 is 1. So you can go over to the left. You can go past the origin this way, over here a little bit. What's the furthest you could go that way? And of course you can see it's negative 3. Now I'm going to get a couple positives in here. 6 plus 3 is 9. Square root of 9 is 3. I'm going to have that one as a point I'm going to graph. 13 is a good one. 13 plus 3 is 16. Square root of 16 is 4. Now I mentioned these negatives here. If I plug in, I'm just going to throw a ballpark. The last number I have on my graph here is negative 5. Negative 5 plus 3 is negative 2. That's out of the domain. So I'm trying to show you an example of a number out of the domain. Negative 4, still out of the domain. Negative 3, though, negative 3 plus 3 is 0. Square root of 0 is 0. So that's the first number that catches in the domain. We're going to call that the vertex. This is actually, if you haven't noticed yet, it's a parabola turned sideways. Or it's a half a parabola turned sideways. So this point that I just found, where the domain now starts to exist, is the vertex of that parabola, going curved that way. Negative 4 works. Sorry, negative 2 works. Negative 2 plus 1 is positive 1. Square root of 1 is 1. So we can deal with that. Now I'll go ahead and plot these points while my dog's drinking water. One dog's drinking water, one dog's eating its dinner. You probably hear all these crazy background noises. Sorry, guys. It's a house full of animals. It's an animal farm. So 1, 2, right 1 up 2. Got a point there. Right 6 up 3. Got a point over there. Negative 3, 0. You'll see I've plotted that vertex point. Negative 2, positive 1. Negative 2, positive 1's there. And then there was my 1, 2, 6, 3. There's 4 points. That's enough. I can plot this thing, connect them. So notice this graph is exactly like the ones before it, except it's been shifted that direction. How far that direction? Well, 3 units. There it is right there. Shifts it left. Anytime you add a number inside the radical, it's going to cause this graph to shift that direction. It's beautiful. All right. So I want you to see what's different about the next ones on here. So the next, it also asks about the domain. The domain would be values bigger or equal to negative 3, as you see right there. X value is bigger. Range is still just positive Y values. So you'll notice this number was inside the radical. I want you to totally change your mindset now and try the same thing with tables with a number outside the radical. One where I'm subtracting, one where I'm adding. Try to find that vertex point, that first point that's within the domain, and then plot it on the graph here. I'll be back in the next segment to see how you did.